So buffer, we can see it's over right now. Buffer. So firstly, we've got to answer by introduction, general information about buffer. You may write here like history, and probably you may discuss about some very famous buffers like blood, of course related to your own major. And hypothesis. Hypothetically, you expect, for instance, when we have water, we expect when we add some strong acids to water, pH drops down, or when we add base, it will be increased, it rises up. And but for buffer, we expect neither acid nor base effects on our buffer. This is our hypothesis, our expectation actually. Materials, let's say acetic acid, sodium acetate, representing acid and conjugated base, I mean acetate. Since for buffer preparation we need it. HCl, NaOH, pH meter. For weak acid we need pH meter as well, I forgot to tell you that time. And what else? Water for sure. On some beakers probably. Let's say Henderson-Hasselbalch equation over HA. And to prepare different dilutions for strong acid and bases, we needed to know some equations like molarity, liter, and even M1 V1 equals M2 V2 to prepare acids. Since from the liquid supply we prepare, that's why as long as it is Lavoie coefficient ratio, we're able to write that. This one is for material part. For method, but again, schematically I drew it, later on you fix it and correct it in a paragraph format. We said we had 4 beakers, buffer, 2 buffers, and 2 beakers standing for water. We add HCl once, 0.1 molar, 10 milliliter as far as I remember. Then we record firstly, we record initial pH by pH meter. So initial pH will be recorded here. Then acid is added, 0.1 molar, 10 milliliter. Then we record to see acid is 10 milliliter is added. Then we record to see how pH is going to be changed. Let's say final pH. I wonder, you remember, you picked the picture from the board and probably that picture is great. Final pH. Let me see if you can see all of it. Yeah. So okay. Final pH. So initial pH, for instance, when we have water, final pH is far less. It dropped down all the way down, probably some units. So distances must be recorded here. Final minus initial. And for the second water, we record initial pH. Since we have different beakers, beakers could be contaminated. That's why, although these are from the same supply, but their pH could be different. We have to take into account all factors. Anyway, we have again water. We record initial pH, and then this time we are going to add here acid. Here we are going to add base. 0.1 molar, 10 milliliter. So our expectation is buffer rises up, and it does. We record final and distances. So for the first one it dropped down, second one rose up, and then for buffer we record initial pH. It was like 4 point something, I wonder 7 or whatever, more or less. And then we added acid. We added 10 milliliter HCl, 0.1 molar, and 10 milliliter, and 10 milliliter NaOH. I'm sorry if I am not getting to you to see it very well. Probably since simultaneously I'm recording and writing, I'm wondering whether you see everything very well properly or not. Forgive me in advance if there is some irritation. Anyway, 10 milliliter sodium hydroxide, and then we record final. If we see initial and final, there is no significant difference. To prove that our buffer works very well, it resisted against the pH changes, and so that it maintained the same pH, with some decimals probably it changed. And distances must be recorded here. This is our method. So we said we did that all in a laboratory, and by the way, we must have forget to say the most important part. We set up a pH meter inside each beaker to record practically corresponding pH for each one. Then raw values. In raw values, we had like 50 milliliter from each initial solution, 50 milliliter water, and the second beaker 50 milliliter water, 50 milliliter buffer, and 50 milliliter buffer, 0.1 molar HCl, NaOH, and each one 10 milliliter. These are raw values. And also corresponding pH must be written, since everything you collect and record inside the laboratory must be written in raw values part. It's corresponding pH that you recorded inside the laboratory for each beaker, initial and final one. Initial and final. That's it. You can tabulate it nicely if you need. And that table, you pick the picture from the lab, even that one helps you. So those, any value, any number inside the laboratory you recorded, I mean scientific numbers, any others I'm wondering, but at least those numbers must be recorded here. And for data processing, let me clean up everything. You might say how we prepared 0.1, all calculation, 0.1 molar HCl, 0.1 molar NaOH, each one 10 milliliter. So theoretically, by calculation, you might say how we prepare this one, how we prepare 4.7 pH buffer. So theoretically, you may say pH equals pKa plus logarithm of A minus over HA. So you've got to find out this one is 4.7. And each of these ones, you must find out concentration equally, no matter in which one. I prefer you write these concentrations with 1 decimals. For example, if you found out, look pH, if this one is 4.7, so we said pKa is 4.7. So probably these two concentrations are equal. Let's say 0.1 molar, 0.1 molar. That's why logarithm of 1 equals 0 and pH equals pKa. So we picked up from each one in equal volume with the same concentration. For example, if we had 50 milliliter buffer, it means 25 milliliter 0.1 molar sodium acetate and 25 milliliter 0.1 molar acetic acid. So these calculations must be written in data processing part. And finally, with practical, you compare this one. This one corresponds the same practical ones. That's pretty sure it does. And about the other ones as well. Probably, even you do not need to compare it, since these values are purely proper. Just you have to do all calculations. How we prepared this one, how this one, and how we prepared buffer with pH 4.7. And then you must say whether your hypothesis is achieved, met, or not. Your hypothesis said HCl. Oh, by the way, data processing is over. So you wrote all these calculations, and then you come in here For conclusion, you may say whether your hypothesis is met or not. In hypothesis, you set your expectation when you have water and you add acid, you expect pH drops down, and when you add base, you expect pH to rise up. So you may just compare it with resultant values, and then for buffer, your expectation is neither acid nor base affects some buffer, and you may just, to support your hypothesis, use some practical values to say whether your hypothesis according to practical experiment is confirmed or not. Finally, for evaluation, different types of error. As ever, instrumentally we dealt with pH meter, so it could be miscalibrated, and also concentrations we prepared could be wrong, and the other errors we may made mistake. We may have made mistake. That's why sources of errors must be recorded here. And finally, in evaluation still part, you may say how to get rid of those types of errors. Thank you, that's it. Hopefully tonight you stay up to date lab report. Forgive us, it was a very long lasting report, but there was no more way honesty.